To solve the calendar problems, we should know the odd number of days. The number of days more than a week is called an odd day. We count a week from Sunday to Saturday. Odd days for the days of a week are: for Sunday, odd number of days is equal to 0. Monday, odd number of days is equal to 1. Tuesday, odd number of days is equal to 2. Wednesday, odd number of days is equal to 3. Thursday, odd number of days is equal to 4. Friday, odd number of days is equal to 5. And Saturday, odd number of days is equal to 6. Odd days for the months are: for the month of January, there are 3 odd days. For the month of February, 0 number of odd days or 1 odd day, because for the month of February we have 28 days. 28 divided by 7 will give you 0 remainder, that will give you 0 number of odd days. Whereas for a leap year we have 29 days in the month of February. So 29 by 7 will leave a remainder 1. So therefore we have a 1 odd day for the leap year in the month of February. For the month of March we have 3 odd days. For the month of April we have 2 odd days. For the month of May we have 3 odd days. For the month of June we have 2 odd days. For the month of July we have 3 odd days. For the month of August also we have 3 odd days. For the month of September we have 2 odd days. For the month of October we have 3 odd days. For the month of November we have 2 odd days. For the month of December we have 3 odd days. These number of odd days have been obtained by dividing the days of the month by 7. So 31 by 7 is equal to 4 into 7 plus 3. So that means there are 4 complete weeks and 3 extra days are there. So these 3 extra days are called odd number of days. In a month which contains 30 days, we have 2 odd days, because 30 divided by 7 is equal to 4 into 7 plus 2. So there are 2 extra days which are more than a week. Therefore 2 odd number of days for a month which contains 30 days. In the month of February we have 28 days. 28 divided by 7 is equal to 4 into 7. So that leaves you a remainder 0. And in a leap year we have 29 days in the month of February. So 4 into 7 plus 1. So we have 1 odd day in the month of February in a leap year. Now we are going to find the odd number of days for a non-leap year. So there are 365 days in a non-leap year. So divided by 7 we'll get 52 into 7 plus 1. So there are 52 complete weeks and 1 extra day will be there in a non-leap year. Therefore number of odd days is equal to 1. So for a leap year we have 2 odd days, because in a leap year we have 366 days divided by 7, 52 into 7 plus 2. So there are 52 complete weeks and 2 extra days. So in a leap year we have 2 odd days. Odd days for a century, that is for 100 years, is equal to 5, because a century contains 24 leap years, because every year which is divisible by 4 is a leap year except this century. So 100 by 4 will give you 25, and subtracting 1 will get 24 leap years. because this 100 year is not a leap year. So the remaining are 100 minus 24, that is equal to 76 non-leap years. Since every non-leap year has one odd day, 76 non-leap years will have 76 odd days, and since every leap year has two odd days, 24 leap years will have 24 into 2, that is equal to 48 odd days. So the number of odd days in a century will be 76 plus 48 is equal to 124, which is again more than a week. So therefore we have to subtract this one all complete weeks in this 124 days. So 124 divided by 7 will give you 17 into 7 plus 5. So there are 17 complete weeks and 5 extra days. So that means 5 odd days are there. Therefore, we can conclude that a century, that is 100 years, have 5 odd days. The number of odd days in 200 years. So 200 is, even though it is divisible by 4, it is not a leap year. So therefore, if I divide this 200 by 4, I have 50, and 100 is not a leap year and 200 is also not a leap year. Therefore, I have to subtract 2 from this 50. I'll get 48 leap years. So therefore, the remaining years are 152, which are non-leap years. So the odd number of days in 200 years is equal to 48 into 2 plus 152 into 1, that is equal to 248 odd days. So this is again having more than 7 days. Therefore, divided by 7, 35 into 7, that plus 3. So therefore, in 248 days, we have 35 complete weeks and 3 extra days. Therefore, 3 odd days are there in 200 years. So odd days in the 300 years. So in a similar way, we can find the odd days in 300 years. 300 years. 300 divided by 4 will give you 75. But in these 300 years, we have 100, 200 and 300 are non-leap years. Therefore, subtracting these 3 from this 75, we will get 72 leap years. 72 leap years. So for each leap year, we have 2 odd days, and the remaining non-leap years are 300 minus 72, that is equal to 228. So each non-leap year has 1 odd day, each leap year has 2 odd days. So together we have 372 odd days. 372 odd days. 372 divided by 7 will give you only 1 odd day, because in 372 days we have 53 complete weeks and 1 extra day. So in 300 years we have 1 odd day. So coming to the 400 years, 400 divided by 4, that will give you 100, and I have subtracted 3 because 100, 200 and 300 are non-leap years. So 100 minus 3 is equal to 97 leap years will be there in 400 years. So 400 minus 97, that is equal to 303 non-leap years. So in 400 years, we have 97 into 2 plus 303, that is 497 odd days are there. But if I divide this 497 by 7, I will get 0 number of odd days, because this 497 has completely 71 weeks. So the number of odd days for 400 years is equal to 1. So the odd days will repeat for every 400 years. 400 years. So the table for odd days are like this. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500, 1600, so on. So for every 400 years, odd days are repeated. Therefore, for 100 years, 500 years, 900 years, 1300 years, 1700 years, and 2100 years, odd days are only 5. And for 200 years, 600 years, 1000 years, 1400 years, 1800 years, 2200 years, odd days are 3. For 300, 4, 700, 1100, 1500, 1900, 2000, 300, the number of odd days are equal to 1. And 400, 800, 1200, 1600, 2000, 2400, for all these years, odd days are 0. So using these calculation of these odd days, we can find uh, for a given date what is the day. So for example, a question is like this: what was the day on 15th August 1947? So first of all, I have to calculate how many number of odd days are there till the end of 1946. So the number of odd days up to the end of 1946 are calculated like this. This 1946 can be divided as 1600 plus 300 plus 46. So again, in this 46 years, I have 11 leap years and 35 non-leap years. Because this 46 divided by 4 will give you 11 leap years and the remaining are non-leap years. So for 1600 we have calculated in the previous calculation. For 1600 we have 0 number of odd days because this 1600 is divisible by 400. And this in this 300 years we have only one odd day. For 11 leap years, 11 into 2, 22 odd days are there. For 35 non-leap years, 35 into 1, 35 leap years, 35 odd days are there. So up to the end of 1946, we have 1 plus 22 plus 35, that is 58, 58 odd days are there. Odd days up to July 1947 we are going to calculate. So January, February, March, April, May, June, July. So for the month of January we have 3 odd days. For the month of February we have 0 odd days. For the month of March we have 3. For the month of April 2. For the month of May 3. For the month of June 2. For the month of July 3 odd days. So the number of odd days up to the end of July 1947 are 16. So up to 15th August 1947, this in 15 days we have only one odd day because 15 divided by 7 will leave a remainder of 1. So therefore, up to 1947 15th August, how many number of odd days are there? 58 plus 16 plus 1. So 75 odd number of days are there. So therefore 75 divided by 7 is equal to 10 into 7 plus 5. So in these 75 odd days, again I have 10 complete weeks and leaving 5 extra days. So till the date 15th August 1947 we have 5 odd days. So when odd number of days is equal to 5, that will give you a Friday. That we have seen in the table uh, in the beginning. So if odd number of days is equal to 5, then the day is Friday. Hope that this clears all the doubts about calendar problems. Thank you very much.